All right, this is section 11.6. 11.6, and what we deal with in 11.6 is we take the probability that we learned in 11.5 and we apply it to events not happening. So they're finding the probability of something not happening, finding the probability of one thing or another happening or not happening. That's what this section is all about. So as you can see in our very first question, you're dealt one card from a 52 card deck. Find the probability that you are not dealt a queen. Well, in the past, what we've seen is we've seen a situation where it was same thing, right? But find the probability that you are dealt a queen, right? And that was easy. And what would we say here? What would we say in a problem like this if it was asked, find the probability you are dealt a queen? Let's do that part first. Let's pretend that we're not caring about the not part, okay? We only care about this. Well, all of a sudden it becomes a problem we've done before, right? We know that there are 4 queens in a deck, right? So the probability of getting a queen would be what? What would it be? 4 out of 52, right? Everybody agree? Let's leave that there for just a moment. So I'm going to just label this mutually exclusive for now. We'll come back to it. Okay, I'm not going to talk about it just yet, but you'll see in a moment. So the probability of something not happening, so the probability of the event not happening, not the event, is going to be 1 minus the probability of that event actually happening. So if we now don't want that to happen, right? If we don't want this to happen, if we want the probability of not getting a queen, then that is going to be 1 minus the probability of getting a queen. Does that make sense? Okay. So now the question is, how do we actually do this? Well, very simple. That 1 is easily converted to a fraction. Whatever your denominator is here, 52, make that 52 over 52 in place of your 1. Isn't that true? 52 over 52 is 1? Yeah. So minus the same 4 over 52. And so the probability of not getting a queen is 1 minus 4 over 52. We just had to get a common denominator. That's easy, right? Which is 48 out of 52. And now we need to simplify. Don't simplify until you get to the very end. Or, I mean, you could. That wouldn't be bad. But just for the sake of seeing the bigger picture for now, we're not going to simplify. You could do it, but I'm not going to go there just yet. All right, so now what can this simplify to become? Well, these are both divisible by 4, right? So divide that by 4 is 12. What's 52 divided by 4? 13. And so now that's the probability of not getting a queen. 12 out of 13. Does that make sense, everybody? Now, let's pause for just a moment and see if we can get to this answer a little bit faster than using the 1 minus. Now, what I'm about to tell you now is optional. But I personally like to think of it this way as opposed to maybe the way that we just did it. So, let's come back to the beginning. You are dealt 1 card from a 52 card deck. Okay, fine. Find the probability that you are not dealt a queen. Well, if you think in your head, you know right away that the probability of getting a queen is 4, just subtract that out of 52 cards, isn't it? You know that there are 4 queens in the deck, so if you don't want a queen, you want the other 48 out of 52 cards, you could start right there. Does that make sense, guys? So you wouldn't have had to do all this. You start with, what do you want? In other words, you could say, find the probability of getting everything, or the way you think of it is find the probability of getting everything except a queen, meaning that we want all the cards that are not queens, 48 of them out of 52. And then we can simplify from there. Does that make sense, guys? Or Again, find the probability of getting a queen, subtract that from 1, you'll get the same answer. Got it? Okay, and that's the first part there. Okay, let's go on and do another one. You are dealt 1 card from a 52 card deck. Find the probability that you are not dealt a diamond. So this previous problem was not a queen. This one is going to be not a diamond, right? If we follow what we've been doing, we're going to take 1 minus the probability of getting a diamond. Everybody agree? So to figure out how to not get a diamond, you first have to know what's the probability of actually getting one. Well, we know that getting a diamond is how many cards?
13.
13. Good job. There are 13 diamonds in a 52 card deck. Therefore, 1 minus those diamonds is going to tell you all the others. Well, couldn't you just fast forward so that you don't have to do 52 over 52 minus 13 over 52 equals what? 39? Is that 39 out of 52? Couldn't you just say from the very beginning here, if I don't want diamonds, how many cards are left? 52 minus 13, which is 39 out of 52. Does that make sense, guys? Okay. So then what does 39 and 52 have in common? 3, right? Or do they?
No, 52 can. 52 divided by
No, that's not it. So it's done, isn't it? Nope. 13. That's right. 13, you guys are absolutely right. So it's 3 out of 4. Does that make sense? Okay, good job. So there it is. 3/4. Does that make sense, guys? Starting to get it? So the probability of not having something happen is really not that tough. Okay? It's just understanding. I removed your chair because I'm recording it right there. Sorry.
I'll send it this way.
Okay. All right, so now let's take a look at this next one. You randomly select 1 card from a 52 card deck. Find the probability of selecting an ace or a jack. Okay, so I'm now going to add another piece here. The probability of getting an A or B. Right? That's what we're doing right now. Are they asking for the probability of not getting something? No. They're asking for the probability of getting something or something else, which is perfectly viable, right? So if we want to find the probability of an or situation, it's very simple. Find the probability of the first one and add it to the probability of the second event. Does that make sense, guys? So if I want to know the probability of getting an ace or a jack, let's go erase this because we don't care about the not one anymore, okay? If I want the probability of getting an ace or a jack, then what I would do is first find the probability of getting an ace, and then I'd add that to the probability of getting a jack. Does that make sense, everybody? Very simple. So now, let's take a look at this one. What's the probability of getting an ace? 4 out of 52. What's the probability of getting a jack? 4 out of 52 as well, because there are 4 aces in a deck and 4 jacks in a deck. Everybody agree on that? Okay. So that's it. Now what? What do we do with these? Add them together. 8 out of 52, because when you add or subtract fractions, you only add or subtract the numerators. You leave the denominator alone, and now we need to simplify that, don't we? It can be divided by 4, can't it? So that's 2 out of what? 13. And that is the probability of getting an ace or a jack. 2 out of 13. Okay? All right, let's keep going. You randomly select 1 card from a 52 card deck. Same concept. Find the probability, or same situation. Find the probability of selecting a red 10 or a black jack. Let's write this out. Probability of getting a red 10 or a black jack. Okay, so let's see here. Probability of getting a red 10. Let's deal with that one first. Probability of getting a red 10. How many red 10s are there in a deck? Is it just one?
2.
Well, let's see here. So we have diamonds, red, spades, black, hearts, red, clubs, black. So there's actually only 2 types of cards that are red, right? So that means there are only 2 out of 52. There are only 2 red colored cards that are 10 in a deck of 52, right? And now let's do the other one. A black jack. Is that the same scenario?
Yes.
Yeah, because there are only 2 types of cards that are black, 2 types of suits that are black, and within them there's only 1 jack. So 2 out of 52, which is 4 out of 52, which reduces to what? 1/13th, right? Good, that's right. All right, there you go. Does that make sense, everybody? All right, we're doing okay on this? Okay. Let's take a look at this next one. I'm going to erase, let's say this one. We got an example there, okay? You randomly select 1 card from a 52 card deck, okay? Same kind of setup. Find the probability of selecting the 10 of hearts. All right. 10 of hearts. Or 4 of diamonds. You with me so far? Okay, so we need to know 10 of hearts. We need to know 4 of diamonds. Let's go figure that out, shall we? How many 10 of hearts are there? 1, right? There's only 1 out of 52. How about 4 of diamonds? 1 out of 52. For a total of 2 out of 52 ways you can get those, which reduces to 1 out of 26. That's it. It's that easy. No big deal. So, any questions about that at all? You doing okay? Okay, let's take a look at this next one. The math faculty, let's do this. The math faculty at a college consists of 6 professors, 7 associate professors, 10 assistant professors, and 4 instructors. If 1 faculty member is randomly selected, find the probability of choosing a professor or an instructor. All right, so let's. I'm gonna do that one over here, shall we? Okay. Okay. So we want to know the probability of getting what? A prof or an instructor. Everybody agree? In order to do that, we need to find the probability of getting a professor and then add it to the probability of getting, no, I guess, you know what I'm going to do? Let me read you this. I'm just going to use P and I, shall we? So probability of getting a professor plus the probability of getting an instructor. Everybody agree? Good? Okay. So let's go do the professor side. How many professors are there? 6. Associate professor doesn't count as 1. Okay. Actual professors, so they're only, and neither does assistant. So there's 6 out of how many?
27.
Very good. You have to add these 6 and 7, 13, 13 and 10, 23, 23 and 4, 27. That is the total amount of people in your sample. Does that make sense, guys? Okay. So 6 out of 27. And then we need to do the instructors. How many are there? 4 out of 27, the same amount. And so that's a total of 10 out of 27. Can we reduce that? No. So that's it. Does that make sense, guys? All right, now let's take a look at the next one. I'm now going to say the following. Not mutually exclusive. And you guys are going to see it in a moment here. Okay? So, the probability of A, let me see here, let me just double check here. Yeah, let's do it that way. Or B is equal to the probability of A plus the probability of B minus the probability of A or B. Okay? Cassie, does that show up on the video, that little corner? Perfect, thank you. All right, let's take a look at this. First and foremost, we need to know what the definition of mutually exclusive is. If we drew a Venn diagram, mutually exclusive means that all the stuff in A is not related to the stuff in B. Is that showing up still? Okay, perfect. So my stuff and your stuff is unrelated in every aspect. Does that make sense, guys? Okay. Not mutually exclusive means that we have what? Overlap. This part right here. That we cannot count double. We have to only count this stuff once. Does that make sense, guys? Okay. So if I have a car and you have the exact same car and we can't have duplicates, we can't have two cars, we have the exact same car. Does that make sense? It's not the very best analogy, but if we're talking about the things we have, we might both have a Honda Accord. So we're not going to say we have two Honda Accords necessarily in our total list of actual, like the names of things that we have, not the quantity, okay? That's not the best example, but you're going to see the connection in a moment. When we're doing not mutually exclusive stuff, we take the probability of this occurring, the probability of this occurring, and then we take out the middle because that means that we don't duplicate anything. Does that make sense? Okay, we'll talk about that. Let's take a look at what it is application-wise. Okay, think back to the professors and instructors one we just came from. There are no professors that are also instructors. There are no instructors that are also professors at the same time, right? That's why they are mutually exclusive areas. Whereas now, let's take a look at this one, shall we? A single die is rolled. Find the probability of rolling an odd number or a number less than 4. Let's go take a look at this. Probability of rolling an odd or a number less than 4. Everybody agree? Okay? Let me put this over here so it looks like it's lined up. Or less than 4. Okay? You with me so far? Same setup, right? Same kind of thing. So that means we need to figure out the probability of getting an odd number. Let's go do that first, shall we? Okay? Probability of getting an odd. What's the probability of getting an odd when we're rolling a dice or a die? How many odds are there? 3. Out of how many? 6. Okay? So, namely, the odds that we can get are 1, 3, and 5. Everybody agree? You with me so far? Okay. Then we need to go figure out and add to that the probability of getting something less than 4. Right? I'm going to move this over a little bit. Oops. 3 out of 6. All right. What are the numbers that are less than 4? 1, 2, and 3. Everybody agree? 1, 2, and 3. So that's what? 3 out of 6. You with me so far, guys? Okay. Minus the overlap. A or B minus odd or less than 4. Meaning that you need to take out what they have in common. Because we already counted the 3. If you add these together, how many 3s do we have in our answer? 2, right? We can't have both of them. We need to take out what they have in common, which is one of the 3s. Does that make sense? You don't want to count the 3 twice. So how many things do we have to take out in the subtraction part here? 1. out of 6.
What about the 1?
Oh, sorry. My bad. 2, 1 and 3. So 1 and 3 are the numbers that they had duplicated. Does that make sense, guys? Sorry, good catch. So 2 out of 6. Okay? Because you don't want to count the 1 and the 3 twice, right? You only want to count them once. Okay? And so therefore, 3 plus 3 is 6, minus 2 is 4 out of 6, or 2/3. Okay? And there it is. Let's type that in. Make sense, guys? Okay. So, let's recap. Probability of one event occurring, probability of the other event occurring, take out each of the duplicates. Not but all of them, you just don't want to count, because if you take it as is, you're going to be counting 2 of the 1 and 3s. We only need 1 set of them to get the accurate probability. Okay? All right, let's keep going. So now, with that said, I'm going to, let's leave this one up as an example, even though it's covered up. How about maybe I back up just a little bit? There, perfect. You are dealt 1 card from a 52 card deck. Find the probability that you are dealt a jack or a red card. Let's go take a look here. So probability of getting a jack or a red card, right? What we're going to need to know is the probability of getting a jack. We're going to need to know the probability of getting a red card. Then we're going to need to subtract any extra overlap of a jack or a red card. Does that make sense, guys? Okay, so first and foremost, how many jacks are there? 4 out of 52. How many red cards are there? 26. Easy to say 13, right? I would easily make a mistake and say 13, but there's actually two suits that are red. They are the hearts and the diamonds, right? So that's 26, or half the deck out of 52. Not plus, minus. Minus a duplicate. So let's take a look here. Are there any duplicates here that are jacks and reds counted twice? And how many are they? 2 of them. Okay, so we have 4 jacks here. We have jack of hearts, jack of diamonds, jack of clubs, jack of spades. Here's the diamonds, here's the hearts. Everybody agree? The red cards would also include every single red, meaning that you would have a diamond jack over here and a heart jack over here, along with all the other red cards. Does that make sense? You don't want to count the diamond jack or the heart jack twice. Does that make sense, guys? So therefore, you must take out one of the duplicates of each, or both the duplicates. Does that make sense, guys? You do not want to count the diamond jacks and the heart jacks twice, and that's the point of that. So therefore, 4 plus 26 is 30, minus 2 is 28 out of 52. Obviously, that's not the answer. Divide that by 4, so that's 7 out of 13. Does that make sense, guys? Any questions about that at all? Okay, good. All right, let's take a look at this one. So let's back up. A little bit tough to see. I'm going to read this one, okay? It says, it is equally probable that the pointer on the spinner shown will land on any one of the 8 regions, numbered 1 through 8. If you can't see that, there it is. Okay, everybody with me so far? If the pointer lands on a borderline, spin again. Fine, whatever. Find the probability that the pointer will stop on an odd number or a number less than 8. Again, are those mutually exclusive? No, because there are odd numbers that are less than 8. Does that make sense? You're going to have overlap in this particular problem. Does that make sense, guys? And that's why you have to use the not mutually exclusive way of looking at it, as opposed to the first 6 problems in our section that were solely mutually exclusive, where they were separate. Okay, so with that said, let's take a look at, say, this problem right here. Okay, and so in order to do it, we need to what? Figure out the probability of what? Odd number or less than 8. That's our scenario. Does that make sense, guys? We are looking for the probability of an odd number or the probability of something less than 8. So therefore, we need to figure out probability of odd plus probability of less than 8 minus their overlap minus their duplicates. Does that make sense, guys? Any questions about that? Okay, what's the probability of getting an odd number? 4 out of 8. Good job. What is the probability of getting a number less than 8? 7 out of 8. There are 1, 2, 3, 4 odd numbers. There are 7 out of 8 numbers less than 8 minus, what are the duplicates? 4 duplicates, right? Because you have 7, 5, 3, and 1 that are both odd and less than 8. Does that make sense? So you have to take out the duplicates, which just leaves you with what? 7/8. Just works out nicely that ends up going. Does that make sense, guys? Hopefully. Okay. All right, let's do this one. Another spinner problem. Same situation, I'll just read the probability question. Find the probability that the pointer will stop on an even number. Okay, let's go set that up. How about I do, we'll do this. Probability of an even number or a number greater than 4. Greater than 4. Okay, so in this problem, we're looking for the probability of spinning an even number or a number greater than 4. In order to do that, we first need to know the probability of getting an even number. What's that, everybody? 4, right? 2, 4, 6, and 8. 4 out of 8. We then need to add to that the probability of getting a number greater than 4. What's that? 4 out of 8. 5, 6, 7, and 8. Then we're going to need to subtract from that the probability of getting an even number or a number greater than 4. What is that?
4. Wait.
Careful.
2.
2, exactly. So what are the numbers that are even and greater than 4 at the same time? Well, these are the numbers that are greater than 4, 5 through 8. The ones that are even are 6 and 8, so just 2 out of the 8 are even and greater than 4 at the same time. And so that's 4 plus 4 is 8 minus 2 is 6 out of 8, or 3/4. Okay. Any questions about that at all? Doing okay? All right. Let's take a look at this one. Let's come back to the professor scenario. You guys remember seeing that earlier? So I'm going to, maybe that's a little too much. This is probably fine. Okay, let's take a look at this. So I'm going to take a moment to go and ask you to make sure you pay attention. Is the problem a mutually exclusive where there's no overlap? Or is the problem not mutually exclusive where there is overlap? Pay attention to that, okay? Because it's not always going to be just given to you like I've been telling you it is. So let's take a look. If there's no mutually exclusive, you just add, right? You don't subtract the overlap. It's just the first part of this. You would just take out this part. Does that make sense, guys? Okay, so let's take a look. Here we go. First, determine, are we dealing with a mutually exclusive situation or not mutually exclusive? The math department of a college has 7 male professors, 8 female professors, 11 male teaching assistants, and 11 female teaching assistants. If a person is selected at random from the group, find the probability that the selected person is a professor or a male. Okay, I'm going to erase this top one right here, just to give us more space. I know I don't have a mutually exclusive scenario. So we need to figure out the probability of getting a professor or a male. Now, is this mutually exclusive? Where they're completely separate, professor and male, totally separate categories? No, because there are male professors and male teaching assistants as well. Does that make sense? Okay, so this is a not mutually exclusive scenario. Does that make sense? Okay, this is where there is overlap. Okay, so let's take a look. So this is indeed a not mutually exclusive scenario because there are professors that are male, teaching assistants that are male, professors that are female, and so on. So there is overlap. So what we need to do is figure out the probability of getting, a professor. Let's go do that. Then we need to find the probability of getting a male teacher of some sort, professor or teaching assistant. And then we need to subtract professors who are also male so we don't have duplicates. Does that make sense, guys? Okay, so that we don't have duplicates. Now, the bottom line is that, well, we'll see this in a moment, but anyways, you could have just done the P and the M if you didn't already see that. But I want to kind of talk about this so that we look at it this way. Anyways, so how many professors are there?
15.
There are 15. There are 7 male professors, 8 female professors. Right? Because you want to find the probability of getting a professor. That means both the male and females, right? And so that's 15 out of how many?
37.
Is it 37? Let's take a look. 7 and 8, 15. 15 and 11, 26. 26 and 11, 37. Good. So we just did all the professors. Now, what's the probability of getting just somebody who's male?
18.
18, right? 7 male professors, 11 male teaching assistants. There are 18 total faculty members out of the 37. You with me so far? Okay. Now, we need to, because this is a not mutually exclusive, there's overlap. There are professors that are both male and female, right? We need to take out the double counting. We don't want to count males and males twice here that we shouldn't. How many professors are both at the same time male? 7. Professors who are also male, 7 of them. That's the extra that you don't want to count. You don't want to duplicate male professors in this calculation, in this probability. It'll mess it up. So there it is. 15 plus 18, 33. 33 minus 7, 26 out of 37. Does that make sense, guys? Did I calculate that right? Just double check my we'll see, right? And we're good.
Why wouldn't you put the male teaching assistants in there?
They are in there.
They're with the males.
They're with the males, right? They're with the males. So they are in there, if you add them all together. Okay, let's move on, shall we? The math department of a college has 8 male professors, 12 female professors, 11 male teaching assistants, and 10 female teaching assistants. If a person is selected at random from the group, find the probability that the selected person is a teaching assistant or a female. Here we go. We're trying to find the probability that we get a TA or a female teacher of some sort, professor or TA. Does that make sense, guys? Okay. In order to figure out the probability of getting a TA or a female, we need to figure out TA. We need to figure out female. And then we need to decide, is this mutually exclusive or is it not mutually exclusive? Do we have overlap or do we not have overlap? We do have overlap because we do have TAs that are both male and female, right? We do have overlap, so we are going to need to take out the duplicates of TAs who are also female. Does that make sense, guys? Okay, so to answer this, we need to figure out the probability of getting a TA, the probability of getting a female, and take out the people who are both TAs and females, so we don't count twice. All right, what's the probability of getting a TA? Well, there are 11 males, and there are 10 females, so there are, out of? 41, good. 41 total faculty here. Then we're going to need to add the probability of getting a female. There are 10 female teaching assistants, 12 female professors, 22 out of the 41 faculty members. But we have duplicates, don't we? Duplicates that we don't want to count, okay? We don't want to count the doubled up one. We want to only count them once. So we need to take out the people who are both teaching assistants and females, which are how many?
10.
10 out of 41. And so 21 plus 22, 43. 43 minus 10, 33 out of 41. I don't think that can be reduced. No. Make sense, guys? Any questions about that at all? Okay, lovely, very good. Okay, let's take a look at this one. You want to be able to read a chart here. So now we kind of change things up just a bit, but we're still dealing with the same concepts. Okay, I leave these up because it's the same concept. Let's take a look here. The table shows the educational attainment of the population of Mars, ages 25 and over, expressed in millions. Okay. Find the probability that a randomly selected Martian, aged 25 and over, has not completed 4 years or more of college. Has not completed 4 years or more of college. So, we want to find out what? What's the probability that we're looking for?
Has not completed 4 years of college.
Not 4 years
Or more.
of college. Does it say or more?
Or
Yes.
just or more.
Yeah, that's actually key. Not 4 years or more. Okay? So, are we doing an or case here? No. We're going all the way back to this, aren't we? Right? So, if that's the case, we know we need to do 1 minus the probability of all the people who are getting 4 years or Martians or more. Take a look at that for a moment. Isn't that true? The probability of not getting 4 years or more college is 1 minus all the people who are getting 4 years or more of college. So let's take a look. We want a Martian aged 25 and over who has not completed 4 years or more. So what is that? If this is the total number of people, this is the total number of people who completed 4 or more years of college. Does that make sense, guys? What does that say about everybody else? They haven't. So they don't talk about males and females, do they? They only talked about the total people. So there are 43 out of how many? 168. That's your denominator, right? You can read your chart carefully. Those are your totals, right? These are the total males. This is the total for females. This is the total people. This is the total who had less than 4 years of high school, 4 years only of high school, less than 4 years of college, 4 or more years of college. That's how you read your chart, right? So if we want to know the number of Martians who have not completed 4 or more years of college, we go find out the Martians who have, which is 43 out of 168 total Martians. If we take 1 minus that, we will find out how many did not. Now, what's the other way to do it? Just add all these up and put it out of 168. Isn't that true? And we should get the same thing. So if you don't, you get 168 over 168 minus 43 out of 168, which is what? 125 out of 168. Now look, that's a lot of work. You could have just said 27 plus 57 plus 41. That should be 125 out of 168 as well. Does that make sense, guys? Go double check that. And isn't that true? There are 27 people, 57 people, 41 people. All 3 of these groups have had less than 4 years of college. It's the people who have not had 4 years or more of college. Does that make sense, guys? Okay, can that be reduced? I don't think so. I don't think it can. Pretty sure that it's not. Maybe by, yeah, that's good. Okay. All right, there you go. Let's go do another one, shall we? Okay. Let's go do this one. All right. So, table shows the educational attainment, same thing. Okay. Find the probability that a randomly selected Martian aged 25 and over has completed 4 years of high school only or is a male. Okay, let's take a look here. So this could potentially be a not mutually exclusive if we have overlap, but we need to pay attention here. So probability that our Martian is what? 4 years of high school. 4 years of high school. Only. Only is key, right? Which tells you what piece. Which one are we looking at here? So just that alone, 4 years of high school only is what?
64.
It's the 64. Because they don't specify male or female for that. Does that make sense, guys? 4 years of high school only, that tells you you're dealing with the 64 in some way. We'll deal with that in a moment. Or is a male. That's the other piece. Or is a male. Where's that? Male is what? What number are we looking at out of the males? The 82. Because it doesn't say anything. They're totally separate right now. We need to decide in a moment whether they have overlap. But for now, high school only, male. Right? Everybody agree? So we would need to find out the probability of people who have 4 years of high school only. Add that to the probability of getting a male. And now, is there overlap between males and high school only? Yes. Right there. Does that make sense, guys? You don't want to count that twice. If you don't subtract 4 years of high school only and the people who are males, you will double it. Does that make sense? You'll double that area. You don't want to have duplicate of this. You only want to count these 31 people who are males and who had 4 years of high school only. You only want to count them once. Okay? So this is a not mutually exclusive. So what's the probability of high school only? 64 out of what?
169.
And that's a very important number as well. Out of 169 total people. Plus what?
82.
82. Yes. out of 169. So what do we just do? What's the probability of getting a person, a Martian, who's 4 years of high school only? There are 64 Martians who have had only 4 years of high school out of a total of 169 Martians. Then, what's the probability of getting a male Martian? There are 82 total male Martians out of all of the Martians who are male and female of 169. But we don't want to count twice the male Martians who have had 4 years or only of high school, or only 4 years of high school, which is 31 out of the 169. Does that make sense, everybody? Okay, so did anybody get an answer for that?
115 and 160.
Okay, and I definitely don't think that, can be reduced. No, I don't think so. But I'm lazy, so I'm just gonna type it in. Okay, we're good. Does that make sense, guys? Any questions about that? This can be a very tricky section, but in general, it's not bad at all. Okay, we move on to the next topic. Odds in favor and odds against. Okay? Odds in favor versus the odds against. Okay? Though that's the final area that we're going to discuss. So, when they say find the probability of an event happening or in favor, you find to find the probability of the event happening, you take the probability of the event divided by the probability of it not happening. Conversely, if you want the probability against something happening, something not happening, everybody agree? We do the opposite. We take the probability of it not happening and divide it by the probability of it actually happening. Okay? Okay? So, odds in favor or odds against. And that closes out our section. So, 1, 2, 3 major areas in this section. Okay? You with me so far? All right, let's go zoom in. Okay. So if you read, find the odds in favor, you jump to this. If you read odds against, you do this. Have we learned how to find the probability of something not happening? Yes. And we certainly know the probability of something happening. Let's go do this together, okay? All right, so a single die is rolled. Good, we know things are out of what? Just 6. Find the odds in favor. Boom, done. We know we're going to deal with this. Everybody with me? So this immediately tells us we're out of 6. This tells us that we're dealing with probability of something actually happening divided by the probability of it not happening. Does that make sense, guys? You with me so far? Of rolling a number greater than 1. There it is, done. That tells us what we're looking for. Okay, so we want to know, how do we write this? Find the probability of rolling a number greater than 1. I don't say not. I'm not saying not here. I'm not saying it to start because we're looking for in favor of something happening. You with me? Okay? All right, so probability of getting something greater than 1 is going to be the probability of actually getting something greater than 1 divided by the probability of not getting something greater than 1. You with me so far, guys? Okay. What is the probability of rolling something greater than 1?
5 out of 6.
5 out of 6. 2, 3, 4, 5, and 6 are all numbers that are greater than 1. So there is 5 out of 6 ways that we can get or roll a number greater than 1. Does that make sense, everybody? What's the probability of not getting or not rolling something greater than 1? 1, because the number 1 is the only one that is not greater than 1, so the probability of not getting 1, or not getting something greater than 1 is 1 out of 6. You with me so far, everybody? Okay. Now we go do the division. Very easy. Whatever comes first on the top in the numerator, that comes first. You with me so far? Whatever's in the denominator goes here. Does that make sense? And we know, or you should know, that division with fractions is really like multiplication by the reciprocal. Now, you may get in the habit where you can just take the top one, put it here, and flip the bottom one and jump straight over there and do multiplication. Does that make sense, guys? It'll work like that every time. Every time, okay? So now, the 6's cancel, and if you do a good job, this will always cancel. And your answer would be 5 over 1 or 5 to 1. Whatever's on top goes first, whatever's on the bottom in the denominator goes second. So your answer is the odds in favor are 5 to 1. Does that make sense, guys? All right, any questions about that at all? Okay. All right, so we have our example. This concept is going to take us to the very end of the section. Okay, so now you have a very good example. I'm going to keep going here. Is it still recording, Cassie? Mm-hmm. Okay, great. All right, let's take a look here. A die is tossed. What does it mean right here? Out of 6. Done. Find the odds against. Okay. That means we're doing a not situation. Odds against mean we're doing something not happening, which means that we do the not part first, and then the actual possibility of it happening second, or in the denominator. Does that make sense, guys? Okay, so when you sit here in favor or hoping that something happens, probability of that goes on top. Whatever is not, that goes on top. They match. Okay? Okay, against rolling a number greater than 1. Okay. Do we need to do much extra work on this one? What's the only thing we have to change in this problem that we just did? It's reverse it. It's reverse, right? The 1/6 is on the top, the 5/6 is on the bottom. Because, and let's go take a look at this, find the probability of not getting something greater than 1 means that you want to find the probability of not greater than 1 over the probability of getting 1. Okay? Or greater than 1, sorry, to be more specific. Well, the probability of not getting something greater than 1 is 1 out of 6. The probability of getting something greater than 1 is 5 out of 6. Everybody agree? Right? And so I am going to literally jump straight to that. Remember I said that? Okay? We know this is happening, but why? We don't need to write that step. And so it's reversed. Your answer is 1 out of 5. Or the odds are 1 to 5. Does that make sense, guys? Okay? And there you go. Okay, so now we have a couple really good examples. And so I'm going to erase this one, okay? And leave that one there. Okay, let's keep going. One card is randomly selected from a deck of cards. We know we're out of what? 52. Find the odds in favor. Are we going to run our problem like this? No. This is odds against. Of drawing a spade. Here we go. Let's take a look here. Find the probability of getting whatever. You get it. I'm such a bad one. How do you even draw? Whatever. Next. So the probability of getting a spade, or the odds in favor of drawing a spade, sorry to be more articulate about it, is that we need to find the probability of actually getting a spade over the probability of not getting a spade. It's probably the worst spade drawn. Okay, so now, what is the probability of getting a spade? 13.
Oh, yeah.
It's the whole suit, right? So it's 13 out of 52, right? There are 13 spades in a deck. It's a quarter of the deck out of 52 total cards. And now what's the probability of not getting that? 39 out of 52. All the other cards. Everybody agree? And so now I'm going to jump straight to the multiplication. 13 over 52 times what?
52.
There you go. 52 over 39. Again, if you do it, set it up correctly, these will cancel. And that's exactly what happened. So 13 out of 39, or 1/3. And so the odds in favor of drawing a spade are 1 to 3. Does that make sense, guys? Okay. All right. Let's take a look at this one. One card is randomly selected from a deck of cards. Find the odds against, not this, right? Drawing a red ace. We want to find out not a red ace. Right, everybody? If we don't want a red ace, then that's what goes in the numerator. And then in the denominator is the probability of getting the red ace. Does that make sense, guys? Okay? So that's how we do this. Odds against means that we don't want to get a red ace. So we find out how many ways we can not get a red ace, divided by how many ways we can get a red ace. How many ways are there to not get a red ace?
50.
50. Why not 51?
Because there are 2 red aces.
Because there's 2 red aces. They didn't say a red diamond. They didn't say a red heart. They just said a red ace. Okay? They said it very specific or a little more vaguely. So that means it's 50 out of 52 or not. Which means how many ways are there to get a red ace? 2 out of 52 ways. And so we write it 50 over 52 times what? 52 over 2. You did it right. So these cancel. So this is going to be 50 over 2 or 25 to 1. So the odds against drawing a red ace are 25 to 1. Does that make sense, guys? Okay, very good. Let's take a look at this next one. The winner of a raffle will receive a 21-foot outboard boat. Okay, I don't think that really matters. If 5,000 raffle tickets were sold, that does matter, right? That's like how many cards you have to choose from, how many sides there are on a die, that kind of thing. And you purchased 50 tickets, okay? What are the odds against you winning the boat? Are we doing 1 or 2? 2. We are going with 2. So, here we go. The odds of not winning, right, everybody? Means that you need to figure out your probability of not winning and divide that by your probability of actually winning the boat. Does that make sense, guys? Winning the boat means what? That they choose your raffle ticket. Everybody agree? So if the odds of winning the boat are based on your raffle ticket, how many ways are there to not win? If there are 5,000 raffle tickets, you got 50 of them.
4,550.
Exactly. 4,950. Everybody agree? There are 4,950 other raffle tickets that could be pulled out of the 5,000. Now, what are your chances or what's your probability of them pulling yours? 50 out of 5,000. Does that make sense, everybody? And now we go set it up. 4,950 over 5,000 times what? 5,000 over 50. The 5,000s cancel. We have 4,950 over 50. I bet that reduces completely down to something over 1. 99, yes. Good job. So your odds against winning are 99 to 1. And that's where you hear that statement come in. Does that make sense, guys? Okay. Let's do another one. Okay. Let's take a look at this. Of the 45 plays attributed to a playwright, 19 are comedies, 13 are tragedies, and 13 are histories. This number is important because they already added those up for you, didn't they? This is an important number. This is like your number of raffle tickets. This is not like your number of cards in a deck. This is like your number of sides on a die. Find the odds in favor of selecting a comedy. 1 or 2? 1. Okay? Odds in favor means that we do it this way. Okay? So I'm going to say odds in favor of selecting a comedy. Does that make sense, guys? Okay? So let's go take a look at this. First, we have to figure out if we're looking for the odds in favor of how many ways that we can select a comedy. How many are there?
19.
Out of?
45.
You got it. There are 19 out of 45, or the probability of selecting a comedy is 19 out of 45. And then we need to divide that by the probability of not getting a comedy, which is how many?
26.
There are 13 tragedies and 13 histories, 26 indeed out of 45. And now set it up. 19 over 45 times what?
45 out of 26.
45 out of 26. 45's cancel. 19 out of 26, or 19 to 26. Because it can't be reduced. Does that make sense, guys? I'm going to skip number 21 because it's just like that. Okay? I'm going to skip 22 because it's just like that. Can you guys see that? Actually, we need to do this one. Because it says comedy or tragedy, and it's not hard. Okay? I just want to make sure you do it. This will be our last problem. Okay? Here we go. Of the 42 plays attributed to a playwright, 13 comedies, 15 tragedies, and 14 are histories. They already added them for you, right? If one play is selected at random, find the odds in favor of selecting a comedy or a tragedy. Why did I say we need to do this one? Because it's the first time we're doing a or case with it, right? It's not tough, but I want to show it to you. 1 or 2?
1.
1. Odds in favor. Okay? All right. Comedy or tragedy. Comedy or tragedy. C or T, not comedy or tragedy. Does that make sense, guys? All right, let's go take a look at how we need to do this. Now, is a comedy and a tragedy, are they mutually exclusive? Is there overlap? There's no overlap, right? You're either a comedy or a tragedy. There's no comedy tragedy. Does that make sense? Okay? Or at least not here. Okay? So therefore, what's the probability of getting comedy or tragedy? You just have to do what? Add them, right? 13 and 15 is 28 out of 42. Does that make sense, guys? It's that easy. Which means that the probability of not getting a comedy tragedy is 14 out of 42. Basically, all the other movies, which are your histories. Does that make sense, guys? Okay? So, probability of getting a comedy or a tragedy, well, just add the comedies and tragedies out of the total number of movies. Not comedy and tragedies, all the others, just the histories. So our setup is 28 over 42 times 42 over 14. 42's cancel. 28 over 14, or 2 to 1. Oops. Oh, crap. Does that make sense, guys? And that'll do it. Number 23 is for you. It's not bad. It's just like this. Good job.